How human beings and planets were created scientifically. Ever wondered how we got here? From swirling clouds of dust to the complex beings we are today, the story of our origins is a fascinating scientific journey. Let's explore the creation of planets and the evolution of humanity, grounded in scientific evidence and theories. The prevailing scientific explanation for the formation of planets is the nebular hypothesis. This model describes how our solar system, and potentially others, arose from a vast, collapsing cloud of gas and dust. Imagine a massive cloud, light years across, slowly contracting under its own gravity. This is the starting point for the birth of a solar system, a process that takes millions of years. These clouds, known as giant molecular clouds, are the nurseries of stars and planets. They are vast and cold, providing the perfect conditions for gravitational collapse. These clouds are primarily composed of hydrogen and helium, the most abundant elements in the universe. However, they also contain trace amounts of heavier elements like carbon, oxygen, and iron, crucial for planet formation. Gravity is the engine that drives the entire process. It pulls the gas and dust particles together, initiating the collapse of the cloud and setting the stage for star and planet formation. As the cloud collapses, it begins to spin faster, much like a figure skater pulling their arms in. This rotation leads to the formation of a flattened disk. The rotating disk, known as a protoplanetary disk, is where planets will eventually form. It's a swirling mass of gas and dust, a cosmic construction site. At the center of the disk, the majority of the mass accumulates, forming a protostar. This is the precursor to a star, a baby sun still gathering material. Within the protoplanetary disk, the dust particles begin to clump together. This is the first step in building larger bodies. Tiny dust grains, initially held together by electrostatic forces, collide and stick. This is the beginning of a long process of accretion. As these clumps grow larger, they begin to attract more material through gravity. They become planetesimals, the building blocks of planets. Planetesimals continue to collide and merge, growing larger and larger. This leads to the formation of protoplanets. These protoplanets sweep up the remaining material in their orbits, clearing paths and growing into full-fledged planets. The process is chaotic and violent. The inner regions of the protoplanetary disk are hotter, influencing the type of planets that form there. This is where the rocky planets are born. The heat from the protostar prevents volatile substances like water and methane from condensing in the inner disk. Only rocky materials can survive. Rocky materials like silicates and metals condense and accrete, forming the terrestrial planets, Mercury, Venus, Earth, and Mars. These planets are dense and solid. The lack of volatile substances in the inner disk explains why these planets are primarily rocky. Water and other volatile compounds had to be delivered later, likely by asteroids and comets. Further out in the protoplanetary disk, the temperatures are much colder. This allows for the formation of gas giants. The cold temperatures allow volatile substances like water, methane, and ammonia to freeze into ice. These ices play a crucial role in the formation of gas giants. Gas giants like Jupiter and Saturn accrete large amounts of hydrogen and helium gas. They become massive, gaseous spheres with rocky cores. Even further out, the formation process is slightly different. Uranus and Neptune are ice giants, containing a higher proportion of heavier elements. Forming at greater distances from the star, Uranus and Neptune had less access to hydrogen and helium. This resulted in a different composition. They contain a higher proportion of heavier elements like oxygen, carbon, nitrogen, and sulfur, primarily in the form of ices. This gives them their distinct characteristics. The early solar system was a chaotic place, with frequent collisions and gravitational interactions. This period shaped the final configuration of the planets. Protoplanets frequently collided, merging to form larger bodies or shattering into smaller ones. This was a period of intense bombardment. One of the most significant collisions was between the early Earth and a Mars-sized object called Theia. This impact is believed to have formed the Moon. Over time, the planets settled into stable orbits, influenced by the gravity of the Sun and each other. This is the solar system we know today. Gravitational interactions between the planets caused them to migrate and settle into relatively stable orbits. This process took millions of years. The Sun's gravity dominates the solar system, shaping the orbits of the planets and keeping them in their respective places for billions of years. Now, let's shift our focus from the formation of planets to the evolution of human beings. This is a story of biological development, driven by natural selection and adaptation. The origin of life is one of the greatest mysteries in science. How did life arise from non-living matter? Abiogenesis is the hypothesis that life arose from non-living matter through natural processes. This is a complex and still poorly understood process. In the early oceans, simple organic molecules formed from inorganic compounds. These molecules were the building blocks of life. Some of these molecules began to self-assemble into replicating structures, the precursors to cells. This was a crucial step in the origin of life. Once life emerged, it began to diversify and evolve through natural selection. This process has shaped the incredible diversity of life on Earth. Early life forms, such as bacteria and archaea, diversified and evolved, adapting to different environments. This was the beginning of the tree of life. Over billions of years, single-celled organisms evolved into multicellular organisms, leading to the development of complex plants and animals. The emergence of vertebrates, animals with backbones, was a major milestone in evolution. This group includes fish, amphibians, reptiles, birds, and mammals. The human lineage diverged from other primates in Africa millions of years ago. This was the beginning of our unique evolutionary journey. The fossil evidence suggests that the human lineage originated in Africa. This is where our earliest ancestors lived and evolved. The split between the human lineage and the chimpanzee lineage occurred approximately 6 to 7 million years ago. This was a pivotal moment in our history. Several key evolutionary milestones shaped the development of human beings. These include bipedalism, increased brain size, tool use, and language development. Walking upright, or bipedalism, was one of the earliest and most significant adaptations in the human lineage. It freed our hands for tool use and other activities. Over time, the human brain grew larger and more complex. This allowed for advanced cognitive abilities, such as problem solving and abstract thought. The creation and utilization of tools was another key development. Tools allowed our ancestors to hunt, gather food, and build shelters more effectively. The emergence of complex language allowed for sophisticated communication and cooperation. This was essential for the development of human societies. The fossil record reveals a diverse array of hominin species, each with its own unique characteristics. These species represent different branches of the human family tree. The fossil record provides evidence of numerous hominin species, including Australopithecus, Homo habilis, Homo erectus, and Homo neanderthalensis. Each hominin species had its own distinct traits, reflecting adaptations to different environments and lifestyles. Some were more robust, while others were more slender. Homo sapiens, our own species, emerged in Africa approximately 300,000 years ago. We are the only surviving member of the Homo genus. The earliest fossils of Homo sapiens have been found in Africa, dating back approximately 300,000 years. This is relatively recent in evolutionary terms. Human evolution is not a linear progression, but rather a branching tree. Many hominin species existed simultaneously, and most of them went extinct. The human family tree is complex and bushy, with many extinct branches. Homo sapiens is just one twig on that tree. Homo sapiens is unique in many ways. We are the only surviving member of the Homo genus, and we possess remarkable cognitive abilities and social structures. We are the sole survivors of a once diverse group of hominin species. This makes us unique and perhaps vulnerable. Our cognitive abilities, including complex thought, reasoning, and creativity, set us apart from other animals. These abilities have allowed us to build civilizations and explore the universe. Our advanced social organization, including language, culture, and cooperation, has allowed us to thrive in diverse environments. We are a highly social species. Our impact on the planet is undeniable. We have shaped the environment in profound ways, and we now face the challenge of ensuring a sustainable future for ourselves and future generations. The scientific story of our origins, from the formation of planets to the evolution of human beings, is a testament to the power of scientific inquiry. It's a story that continues to unfold as we learn more about the universe and ourselves. Ready to delve deeper into the mysteries of the universe and the intricacies of human evolution? Explore further by checking out the resources in the description below. Like this video, subscribe to our channel for more science-based content, and share this knowledge with others. Let's continue to explore and understand the world around us. Together, what does God say about creatures? Please subscribe and follow next video. Thank you.